Today we are looking at week 7, day 4. And we've got a calculation which is 6/9 take away 3/18. 6/9 take away 3/18. Just move that back a bit so you can see. Okay, I am going to show you this using my using the rods. I know you're probably thinking, oh, Mrs. Walker, she loves those rods. And I do, because I think it shows it really well. And we haven't subtracted until now. We've just added. So I'm going to show you how you would set this out so you could subtract using your concrete resources. Okay, so we've got 6/9 and 3/18. So I'll draw it out next to it actually, so you can see as well. So I've got 2 holes. 1 hole, 2 holes. And I'm going to put them one on top of the other because we're going to compare them. So I'm going to have... Oh, am I going to be able to fit this on? I might have to move a little bit further back. There we go. Okay, I need my hole split into 18 equal parts first. I'm going to split I'm going to put my 8. Actually, no, I'll do it the way I'll draw it out. So because we know that there's 2 lots of 9 in 18, I'm going to split my first bar into 9ths, and then I'll show you how you can split your second bar into 18ths. So for 9ths, I'm going to third it first. I'm just try and split it as equally as I can into 3 equal parts. Yeah, that looks okay. And then those are thirds. So if I third them again, I'll have 9ths. So let's see, 1, 2, 1, 2, 1, 2. Now, if you're trying to do this, it's always best. I would try and use squared paper or use a ruler and go for the 18 centimeter. Go for 18 centimeters long so that you can split them equally and evenly. And then I know that in my 18ths, I know I need those 9 equal parts. Let's just double check I've definitely got 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have. I've got 9. I would then just half those because I know that 2 lots of 9 equals 18. Here's a little hint and tip for you. Okay, so that's my pictorial method. That's my bar drawn out. It's my bar model drawn out. I'm going to show you with the cubes as well if I can fit them on the screen. Let's hope I can. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it's going to be a very long bar. 11, 12, 13, 14, 15, 16, 17, 18. Okay, I've got my 18ths. And I've got my 9ths. So I've got my 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, using the rods and drawing it out, it does take an extra little bit of time. But until you're confident at finding a common denominator, use the pictorial or use some concrete resources. But if you're totally happy and you can see straight away that you can turn these into 18ths and find that common denominator and then subtract, go for it. Absolutely go for it. I'm just showing you it this way if you find this tricky still. Okay? Okay, so we're starting with 6/9 and I need to subtract 3/18 from it. So I've got 1, 2, 3, 4, 5, 6/9. So I'm going to forget about those for a minute because I don't need them. I just put those out so I have my whole split into 9 equal parts and my whole split into 18 equal parts. So I'm also going to get rid of those because they still represent 18ths. Okay, does that make sense? Yeah? So I've got 6/9. 1, 2, 3, 4, 5, 6/9. And I want to subtract 3/18. So I need to think, right, how many 18ths is equivalent to 6/9? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I know that if I turn these 9ths into 18ths, I'm going to have 12 of them. So I would have 12 18ths. So let's just double check that by working out the relationship. So we said that for every 9th there was 2 18ths. So multiply that by 2. Yes, I've got 12. So now all I've got to do is take away 3/18 from my 3/18 from here and see how many 18ths I've got left. So I can ignore my 9ths. So now I'm done with them, not bothered about them anymore. So I just needed to subtract 1, 2, 3, and then I'm bothered about these ones here, these 18ths here. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 12 18ths. Take away 3/18 equals 9/18. So that's it shown with the concrete, with the pictorial, and in the abstract. Just going to go through it in the abstract with you because it's obviously the first time we've come across it, and I'd like you to see how it works so we can really try and push on our progress to working in the abstract rather than going straight away for the concrete. Because once we've got this cracked, we're laughing. Okay, so what we would do is we'd look for the common denominator, which in this case we're going to use 18. Okay, we're going to use 18. We can't turn these 18ths into 9ths because we can't half the 3 really. What we would have to do is we'd have to turn these 18ths into 9ths, so we could divide this 18 by 2 as a calculation, but we can't do that with the 3. So what we're going to do instead is we're going to change these 9ths into 18ths by multiplying these by 2. Okay, so bring them down. That's going to be still 3/18 because we're working as 18 as our common denominator, and multiply your numerator again by the same number that you've multiplied your denominator by, because you're changing the value. You're not changing the value, you're changing the representation. Okay, so we've got 12 18ths. Most important thing here, and people make mistakes with this so many times because they just go into an automatic, okay, pull this down, turn it into 18ths, la 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 la, and everybody's head just seems to want to add them. Happens all the time. Most important thing is that symbol there. It is a subtraction. Do not add them. So 12 take away 3, because we know they're in 18ths, we just need to focus on our numerator, is 9. Ooh, and look at that. It's equal to a half. Lovely. Okay. All right, next question. I hope that made sense. Rewatch it if it didn't, or get in touch with me or one of your teachers if you think, oh no, I still don't get that. Okay, because that's fine. All right, next question. 2/5 and 5/10, and I am just going to go through this one in the abstract because we have added fractions loads. Cool. So I'm going to work to 10 as a common denominator. Can you spot why I'm going to work in my 10? Yeah, 5 is prime number, so I can only divide it by itself and 1. So instead I'm going to multiply my denominator 5 by 2 to give me 10. So pull that down. It's going to stay as 5/10. Pull this down, and we're going into tenths now. And 2 times 2 is 4, minus 1 is 3. Quick maths. And now we can add them because we've got an add sign, and we're working in a common denominator of 10. 4 add 5 is 9, and we're in tenths, so we've got 9/10. Happy days. Lovely. Ooh, sequences. I like this next one. Okay, sequences of fractions. So I'm going to write this one out. What is the next fraction in the sequence? So look at it. Just take a second to look at it and see if you can spot a pattern. Okay, so what's the same and what's different? What's the same is that these are all 1. Also, we're in 9ths. What's different? Yeah, numerator is different. Okay, so let's focus on that because that's the different thing, isn't it? How different are they? Can you spot a pattern in the differences? Yeah, it's going up in 2/9 each time, isn't it? So if that's 4/9, 6/9, 8/9, Well, we know that the next is going to be 10 ninths, isn't it? So we'll pop in there 1 and 10 ninths. Happy with that? Good. I hope you just screamed no. We can't leave this as 1 and 10 ninths because 10 ninths is an improper fraction. So that doesn't make sense. So what we've got to do instead is we've got to think, right, if I add in 2 ninths to this, it's going to be 10 ninths. So what's that as a number? What's that as a mixed number? Well, it's 1 and 1/10, isn't it? Yeah? So what we're essentially doing is we're going into the next whole, which is going to be 2. And then we've got 1/9 because we've added 2 ninths, which gave us 10 ninths, which is the same as 1 and 1/9. And we add that 1 and 1/9 to the previous 1, which gives us 2 and 1/9. Does that make sense? Sometimes it works if you draw it out on a number line and you have, let's have a look, we've got, say, let's just start off with, let's go in ninths, so 1, 2, 3, 4, 5, 6, 7, 8, and I'll have to extend it this way, 9, lovely. Okay. And we've got 1 and, we'll start with 1 and 4 ninths, 1 and 4 ninths, 1 and 5 ninths, 1 and 6 ninths, 1 and 7 ninths, 1 and 8 ninths, and I'm not going to write 1 and 9 ninths. What am I going to write? Yeah, I'm going to write 2. And then 2 and 1/9, absolutely. 2 and 2 ninths. 2 and 3 ninths. Okay, so what I'm going to do on this side is I'm going to look and see how many it goes up each time. So that's the first, from there to there, from 1 and 6 ninths to 1 and 8 ninths. Number 2 is 2 and 1/9. So sometimes it helps to do it on a number line as well and list your fractions out like that. Okay, lovely. Right, next question. Looking at values. Okay. All right, here it might help you to put your place value headings. So you can put your ones, your decimal point, your tenths. So some people like to do it like this. Other people like to do it like that so you can see that it's a tenth, yeah? And then our hundredths, or you can set it out like that. And we don't have any thousandths, so I'm not going to list the next. And it is 7.41. And the question is, what is the value of this 4? Well, we know that it is 4 tenths because it's in the tenths column. So you can either leave it as 4 tenths as a fraction, or you can leave it as 0.4, or you could write it out as 4 tenths.